trillion addresses. So how you can compare that, how long it is? Let's do it by this way. If you have to assign IP address to this planet Earth, what you can do, you can assign 67 billion IP address to just 1 centimeter square piece of the sun. What you can say, there is not any possibility that this address can be finished. Let's look another one important example in comparison that if we say IPv4 weight 1 gram, then total IPv4 address weight will be around 1/76 time of Empire State Building. Means only this portion. Then if we say IPv6 address is of 1 gram, then total IPv6 address space will be 56.7 billion times of the weight of Earth. So you can see that the problem that we are facing here nowadays, that IPv4 address space is going to be finished within next 3 or 4 years. IPv6 will take place and redesign the whole internet with gamut possibilities. IPv4 header is variable in length, and you can see its header is quite complex. Whereas IPv6 header is very simple. It is variable, whereas IPv6 header is fixed length 40 byte header. By making it fixed length, what you got better CPU utilization, simplicity in the whole infrastructure. So by designing IPv6, what the developers do, they remove certain fields from the header, that if the you can say header is fixed, we don't need internet header length. We know it is fixed, it is 40 byte, we can remove this. Along with that, there is no need for the fragmentation, because fragmentation is a highly CPU intensive application. What developers say, let the fragmentation do by the end devices, your machines. Next slide. If we have to represent IPv6, how will we do that? IPv4 address is 32-bit address. You normally represent it by dotted decimal 4 octets. Whereas IPv6 address 128-bit address. So for the representation of this long address, what we do, we have to represent it with hexadecimal characters, and we have 8 characters of hexadecimal to represent complete IPv6 address. It's look little bit scary, but when you learn how to implement IPv6, it will be a very interesting to design some mapping and various of this IPv6 address. Again, working wireless infrastructure. How Working will introduce mobile operation that currently not deployed but will deploy soon by 2008 or 2009 using IPv6. Every mobile needs IP address. While mobile needs IP address, it needs to register itself to the working network. And you know that IP address has two parts, network part and host part. Network part means representation and identification of site. That's, for example, this mobile is in Karachi, this site, it has a specific network address. A mobile will be in this side Lahore, it has another network address. And the second part is host part. Host part identify end user, that mobile node. How do you identify it? We'll do it in the next few seconds. The network part will be advertised by aggregator router, that is this one, to the mobile node. That this part, /64 part, has been brought by your mobile. The network address has been available to the mobile, but the host part will be generated by the mobile node itself. How? Using MAC address. Every mobile will have MAC address. So the network part plus mobile part, the combinedly unique 128-bit IPv6 address available. Means end user don't have to manually configure IP address. Mobile will configure by itself, and this procedure is known as stateless auto configuration. Same will be happen for the mobile if it is online in the log. The prefix advised by the router, and the stateless auto configuration will work, and you can see that this IP address assigned to this mobile, this IP address assigned to this mobile. Now if they have to communicate and this is a voice call, tell me it will be a TDM or IP based? IP based means voice over IP will be taken to the action in this voice form. So this packet, voice packet will be carried all the way to the MPLS code to this next side, and the second packet from the end user to the source. Now you know how to represent IPv6, but how to implement it? We will check in this section. There are two options available. One, we have migration, or second, we have coexistence. These are the two models. Tell me which one will be preferred. Coexistence. The reason for coexistence is very important, because migration is never preferred by IPv6 expert. Because while migrating your IPv4 whole infrastructure to IPv6, what you need? You need to redesign whole infrastructure, reassigning the IP addresses. During this time, your network will be completely down. For that reason, you need to go for coexistence model. Also, coexistence model help you in number of ways. That there is no fixed date to convert your IPv4 network to the IPv6. You can do it today, start from today, do it from one machine, one server. Next month, if you check that the service run okay, you will do next 3 machines, next 4 routers, and so on. There is no need to convert all at once. In coexistence model, you can do this portion, make this network is IPv6 network, this network is IPv6 network, and communicate through IPv4. Then there are different mechanisms available to implement coexistence model. You can choose anyone based on your requirement. And this integration of IPv4 and IPv6 will be smooth. Means no network outages, no cost, no problem for the enterprises. What are these techniques of coexistence? These are dual stack, tunneling, and transmission. Let's see what the dual stack. What dual stack means? Dual stack says your end machine will have both the protocol stack. Both protocols can be IPv4 protocol and IPv6 protocol stack. If this device needs to communicate with IPv4 network, it can do it via this protocol stack. And if you have to communicate with IPv6 route, it can do it through this. Means that machine has the capability to smoothly communicate with every part or any part of your infrastructure. Next, tunneling technique. If, for example, you have a problem and you cannot configure this portion as a dual stack or IPv6 infrastructure, what will you do? There are certain limitations. So what you do? You will use tunneling technique. What tunneling technique will help? It will help in a way that this IPv6 cloud and this IPv6 cloud can communicate their infrastructure via IPv4 tunnels. Means IPv6 traffic will go from this router to this router through IPv4 tunnels. The dual stack technique is the most preferred one. But the problem nowadays we are facing here in Pakistan or all around the world, internet is IPv4. Dual stack, not more, you can say 50% of the internet